So, good day everyone. Ayan, so ito po yung mga next na ating pag-aaralan. Ayan, tungkol sa Euler's Generalization of Fermat's Theorem. So, wag na natin siyang patagalin. Start na tayo, no? Ayan. Ayan. At the end of the session, the students will understand the Euler's tangent function or Euler's phi function, solve the problems involving Euler's theorem, and find the last digit of power using Euler's theorem. Dito, based dun sa ating learning objectives, before natin siya matackle, yung Euler's theorem, yung sinasabi natin, alamin muna natin ano ba yung sinasabi nating Euler's tangent function. Ito yung unang dapat natin pag-aralan o yung tinatawag nating Euler's phi function. So ano nga po ba yung Euler's tangent function or Euler's phi function na sinasabi? So sabi dito, the tangent function phi of n, also called Euler's tangent function, Euler's phi function is called is defined as the number of positive integers less than or equal n that are relatively prime to n, where 1 is counted as being relatively prime to all numbers. In short, phi of n equals number of integers 1 is less than or equal m is less than or equal to n, for which the greatest common divisor of n and m equals 1. So sinasabi natin dito na kapag sinabi nating relatively prime, ayan, pag sinabi nating relatively prime, ayan, ibig sabihin yan, yung GCD ng ang GCD ng N and M natin ay dapat mag-equal sa 1. So kapag nag-equal sa 1 yung GCD ng N and M, ang tawag sa kanya relatively prime. So ibig sabihin, in a particular number of positive integers is less than or equal to N, ilan yung bibilangin natin kung ilan yung mag-relatively prime doon. So, yun yung sinasabi nating Euler's tangent function. Yun yung konsepto ng Euler's tangent function. So, ibig sabihin nun, bibilangin lang natin kung ilang relatively prime na meron sa number of positive integers na yon. So, here's, alimbawa na lang, no? Yung tangent function ng 5. Ayan. Yung So, hanapin natin yung phi of 5 na yan. Ano ba yung ilan ba yung mga relatively primes meron dyan sa 5? So, unang-una natin gagawin is you have to list from 1 to 5. So, 1 and 5, 2 and 5, 3 and 5, and then 4 and 5. 5 and 5, hindi na natin siya isasali kasi same lang naman sila. Ayun. And then, after nun, kukunin mo yung GCD ng lahat ng mga to. So, bale, ang GCD ng 1 and 5 is 1. Ang GCD ng 2 and 5 is 1 also. Ang GCD din ng 3 and 5 is 1. Ang GCD ng 4 and 5 is 1. So, then, bibilangin mo lang yon kung ilang yung 1 dyan. So, 1, 2, 3, and 4. Therefore, ang phi function ng 5 natin has a 4. Ayan, 4 relatively primes. So, another example naman dito is yung 12. Let's say, halimbawa yung 12. Kunin natin yung phi function ng 12. Ayan. So, unang natin gagawin, silista lang natin. We have 1 and 12, 2 and 12, 3 and 12, 4 and 12, 5 and 12, ayan. 7 and 7, 12, 8, 12, 9, 12, 10, 12, and 11, 12. Ayan. And then, kunin natin yung GCD ng mga yan. So, ang GCD ng 1 and 2 is 1. Ang GCD ng 2 and 12, that is a 2. Ayan. Ang greatest common divisor ng 3 and 12 is 3. Ayan, tama. Ayan, 4, 12 is 4. Ang 5 and 12 is 1. Ang 6 and 12 is 6. 7 and 12 is 1. Kasi prime number siya. 8 and 12, that is 4. Ang 9 and 12, that is, let's say, 3. Yan. 10 and 12, that is 2. And 11 and 12, that is 1. Then, bibilangin mo lang yun. So, 1, 2, 3, 4. So, ibig sabihin, ito lang, ang part na ito, ang nag-relatively prime. Ayan. And then, apat ang nag-relatively prime. So, ibig sabihin, ang phi of 12 natin equals, easy natin yung equal. Ayan. So, ang equal natin, ang equal dyan is 4 din. Ayan. So, ganyan lang yung example niyan. Yan yung konsepto ng Euler's totient function na sinasabi. Okay? Next tayo. Ayan, ang properties of Euler's totient function. So, meron tayong tatlo. Ngayon, so, if P is prime, then phi of P equals P minus 1. So, kapag prime number kapag given yung prime number, then yung prime number, subtract lang natin siya kay 1. So, just like example here, ayan, kung mapapansin ninyo, prime is 5, sinubtract lang siya sa 1, so naging 4. Ayan. So, kasi ang 5 minus 1, that equals 4. Ayan. So, ganun lang siya kasimple, ano? And then, if P is multiplicative, then P of Mn equals P of M times P of N if the GCD of M and N equals 1. So, tatimes mo lang yon, tatimes mo lang siya, ayan. Tatimes mo lang yung P ng dalawang number na dapat yung M and N natin ay dapat mag-i-equal sa 1. So, ibig sabihin, kapag hindi nag-equal sa 1, kailangan mo pa siyang i-factor out pa ulit. I-factor pa ulit ang i-factor hanggang doon, hanggang ang GCD mo is 1 na. So, ibig sabihin, ang ginagawa lang natin dito is you have to apply the prime factorization. Ayun. Next, the let P is prime. Then, kapag, and phi of P raised to N equals P raised to N minus P raised to N minus 1, where N is natural numbers. So, magkaiba sila ng property number 1 and property number 3. Yung property number 1 kapag original na prime numbers lang. Ayan. So pag pagpilang, wala tayong tinatawag na wala tayong exponent dito, walang nakalagay, subtract lang natin siya kay 1. Pero kapag may exponent na, we have to use equal. We have to use this third property. I mean, we have P raised to N minus P raised to N minus 1. So we have here the example here. We have P of 9. So kukunin natin yung phi function ng 9. So this solution here, the phi of 9 is the same as the phi of 3 squared. So, mapapansin nyo, mayroon tayong exponent na 2, mayroon tayong exponent. So, apply lang natin yung sinabi natin dun sa property number 3. Yung isusubtract natin yung 1 yung exponent. So, magiging phi of 3 squared equals phi squared minus 3 raised to 2 minus 1. Then, 2 minus 1, that is 1. Then, we have to simplify. We have phi of 3 squared equals 9 kasi 3 squared minus 3. Ayan. Then 9 minus 3, the answer is the phi of 3 squared equals 6. Next, if you have here the phi of 13, so since 13 is a prime number, you must apply the first property, which is you subtract to 1. So phi of 13 equals 13 minus 1, then the phi of 13 equals 12. Next, we have phi of 24. Ayan. So, para ang una natin gagawin, yun nga yung sinabi natin kanina, we have to use the prime factorization. Pero dapat, ang prime factorization natin, kapag tayo nagpa-prime factorize, we must always in exponential form like this para ma-apply natin yung third property. So we have here that phi of 24 equals the phi of 2 cube times 3. Kasi prime factorize natin siya, yung 24. Ayan. So, therefore, dahil multiplicative yan, you must apply the second property, which is yung paghihiwalay natin yung dalawa. We have P of 24 equals P of 2 cubed times P of 3. And then, you must apply the properties. Dito, apply natin yung third property, and dito, first property. We have 2 cubed minus 3 minus 1, that is 2. Ayan. So, magiging 2 cubed minus 2 squared na siya, times 3 minus 1 kasi si 3 is a prime number. Ayan. So, then sinusubtract lang siya kay 1. And then, simplify na agad natin. You have 2 cubed, that is 8. Minus 2 squared is 4. Ayan. Times 3 minus 1, that is 2. Ayan. And then, 8 minus 4 is 4. Times 2. Ayan. Then, 4 times 2. The answer is the P of 24 equals 8. Ayan. Next, we have phi of 165. So, ganun lang din. We have to prime factorize. The phi of 165 is the same as or equal to phi of 3 times 5 times 11. Ayan. So, since factorize na itong mga ito. Ayan. Ayan. Then, paghiwalay natin, dahil multiplicative yan, we have phi of 165 times times P of 3 times P of 5 times P of 11. Then, since 3, 5, and 11 are the prime numbers, we have to subtract to 1 or apply the first property. And we have 3 minus 1 times 5 minus 1 times 11 minus 1. And then simplify, though 3 minus 1 is 2, 5 minus 1 is 4, 11 minus 1 is 10. Then we have to multiply it. 2 times 4, that is 8 times 10. So we have the phi of 165 equals 80. Next, phi of 528. Ayan. So we have to use the prime factorization. So which is the 528 is the same as the phi of 2 raised to 4 times 3 times 11. Then we have to separate. We have phi of 528 equals phi of 2 raised to 4 times 2 times phi of 3 times phi of 11. Then you apply the first properties. We have phi of 528 equals 2 raised to 4 minus 2 cubed because 4 minus 1 is 3. Ayan. Times 3 minus 1 times 11 minus 1. Then simplify. 2 raised to 4 is 16 and 2 cubed is 8 times 3 minus 1 is 2, 11 minus 1 is 10. So 16 minus 8, we have 8 times 2 times 10. Then 8 times 2 is 16. Times 10, we have 160. Ayan. So the last example here, we have P of 1,695 is the same as the P of 3 times 5 times 113. And then we have to separate. That will give you as P of 1,695 equals P of 3 times P of 5 times P of 113. Then subtract to 1 all of prime numbers or apply the first property. We have 3 minus 1 times 5 minus 1 times 113 minus 1. Then 3 minus 1 is 2, 5 minus 1 is 4, 113 minus 1 is 112. Then you have to multiply it. The answer is P of 1,695 equals 896. Ayan. So, so pwede nyo i-post. Pwede rin nyo rin i-try yan. No? So, ayan. So, ito yung mga dapat ay susubukan natin. So, dako na tayo sa Fermat's-Euler's theorem or Euler's theorem. By the way, bakit siya tinawag na Fermat's-Euler's theorem? Kasi, kaya siya tinawag na Fermat's-Euler's theorem, pag sinabi kasi natin Fermat's theorem or yung tinatawag natin Fermat's little theorem, ini-state lang doon na if A raised to P minus 1 is the congruence of 1 modulo P. Ayan. So, ibig sabihin nun, pag sinabi natin Fermat's little theorem, ang ginagawa natin dito, or ano ang ini-state lang niya rito is, if you multiply the any number of integer A divided by the prime number, which is yung P kasi is represents a prime numbers. Ang magiging remainder niyan will be give you as 1. So ulitin ko, yung A, yung any kind of number integer raised to P minus 1, divided by the P, which is yung prime numbers, the remainder is 1. So yun yung sinasabi natin Fermat's Euler theorem, Fermat's little theorem. Kaya siya naging Fermat's Euler's theorem kasi generalized ni Euler's theorem. Kaya kung mapapansin natin, tinawag siyang Euler's generalization of Fermat's theorem. So ibig sabihin, generalized ni Euler. So ano ba yung Euler's theorem function na yan? So naiintindihan na agad natin si Fermat's, alamin na agad natin ano ba si Euler's theorem. Euler's theorem states that if GCD of A raised to n equals n equals 1, then the A raised to phi of n is congruence of 1 modulo n. Here, phi of n is Euler's totient function, the number of integers from 1 to up to n minus 1 which are relatively prime to n. When n is a prime, this theorem is just Fermat's little theorem. So ito yung formula natin, o ito yung formula ng ating Euler's theorem. Na yung P of n natin, ito yung tinatawag nating Euler's totient function. That's why kaya pinag-aralan muna natin ano ba si Euler's totient function. And then kaya siya tinawag na Euler's theorem kasi ini-state na lang dito na if we have a number of integer a divided by the n, which is the number that the relatively prime to a, relatively prime, ang magiging remainder natin si 1. Ayan, so yun yung pinaka-explanation niya. Kung si Euler's theorem, magiging remainder niya si 1 kapag dinivide natin yung number of integer doon sa prime numbers. Dito naman, yung pag dinivide natin yung number of integer doon sa ka-relatively prime niya. Therefore, ang remainder niya si 1. So, ganyan lang yung ibig niya sabihin. So, kapag P ito, kapag prime yung N natin, gamitan lang natin ng Fermat's little theorem. Yun. Yun yung sinasabi dito. When N is a prime, this theorem is just a Fermat's little theorem. So, ano po ba yung example here? So, meron tayong example. Use Euler's theorem to find the remainder when 17 raised to 341 is divided by 5. So, this is the solution. So, ang una natin gagawin is you have to identify if the A and N is the relatively prime. So, we let A equals 17 and N equals 5. So, the GCD of 17 and 5 is 1. So, ibig sabihin relatively prime siya. Bakit natin siya kailangan nating i-test kung ito ba ay relatively prime? Kasi kapag yan ay hindi relatively prime, meron ka pang ibang gagawin. Ayan. May gagawin ka pang iba. So, ibig sabihin, yung 17 mo, ifa-factorize mo pa yan. Hahanap ka ng factors na yung isa doon, prime number. Ayun. So, yun ang pipiliin natin, yung prime number na yan. So, since hindi naman sila, nag-relatively prime naman si 17 and si 5 kasi sila ay prime numbers. So, ang GCD ng 17 and 5 is 1. And then, we have to apply the formula of the Euler's theorem. So, we have 17 raised to phi of 5, kasi sinubstitute lang natin, is the congruence of 1 modulo 5. And then, you have to identify the phi of 5, yung totient function ng phi of 5, which is si 4. Kasi 5 is a prime number when you have to use the first property of totient function. So, 5 minus 1, that is 4 na siya. Kaya 17 raised to 4 is congruence of 1 modulo 5. And then, ang gagawin natin sa 4, i-divide natin dito sa original na exponent yung 341. So, i-divide natin si 341 by 4 using Euclidean algorithm. So, ito yung Euclidean algorithm na sinasabi natin. So, ito yon. So, 341 equals 4 times 85 plus 1. Anong gagawin natin dito? Ito yung pang-multiply natin dito para mag-exact dun sa 341. So, ang mangyayari, we have to from here, we have to raise to 885 both sides. So, 17 raised to 4, raised to 85. Ayan. Raised to, ayan. So, i-raise lang natin siya sa 85 both sides. Then, multiply by 17 both sides. Times 17 modulo 5. Kaya magiging 17 raised to 4 raised to 85 times 17 is congruence of 1 raised to 85 times 17 modulo 5. Ayan. And then, total natin magiging 17 raised to 341 is congruence of 17 modulo 5 kasi ito na siya. Kinancel na agad natin ito kasi 1 raised to 8 raised to 85 is the same as 1 lang. So, wala na tayong ano dyan. Kakancel na lang natin yan. Ito na lang ang papakialaman natin. So, ang gagawin naman natin dito next, divide natin yung 17 kay 5, which is 17 raised to 341 is congruence of 17 modulo 5. So, pag dinivide natin yan, ang makukuha nating remainder will be 2. Kaya, ang sagot natin dito is 17 raised to 341 is congruence of 2 modulo 5. Ayan. Sana na-gets ninyo, ano? Next. Use Euler's theorem to find the remainder when 29 raised to 202 is divided by 13. So, ganun lang din yung same process lang kanina. Identify natin if the A and N is relatively prime. So, A is 29 and N is 13. Then, get the GCD of the two, which is ang GCD ng 29 and 13 is 1. Then, you have to use apply Euler's theorem. Yan, or formula of Euler's theorem, which is 29 raised to p of 13 is congruence of 1 modulo 13. So since 13 is a prime number, the totient function of 13 is 12. And kaya 29 raised to 12 is congruences of 1 modulo 13. And then yung 12 natin, divide lang natin siya sa 202 kasi yun yung given natin kanina. So, ang equation niya is 202 or 202 equals 12 times 16 plus 10. And then from here, so ito na yung ating ano, no? From here, and then you have to raise both sides by 16 times 29 raised to 10. So magiging 29 raised to 12 raised to 16 times 29 raised to 10 is congruence of 1 raised to 16 times 29 raised to 10 modulo 13. Then cancel this. Magiging 29 raised to 202 or 202 is congruence of 29 raised to 10 modulo 13. And we know na 29 is divided by 13 has the remainder of 3. Bakit natin siya dinivide? Kasi kapag sinimplify natin ito, ang makukuha nating answer mas lagpas pa sa bilyon. So maraming numbers yon, lampas pa sa bilyon yon. So para mas madali, we have to paliitin natin itong number na ito. Itong base na ito, i-divide lang natin siya sa 13. Then yung makukuha nating remainder, yun yung ipapalit natin sa 13 sa 29, which is yung remainder natin is yung 3. Pag dinivide natin sa 29 divided by 13. And then you have to substitute 29 into 30 into 3. So magiging from 29 raised to 10, magiging 3 raised to 10 modulo 13 na lang. And then, simplify na agad natin. Simplify na agad natin. 3 raised to 10 divided by 13. So pag dinivide natin siya, ang makukuha nating remainder dyan is 3. And therefore, the answer is 29 raised to 202 is congruence of 3 modulo 13. Ayan. Next, use Euler's theorem. So, ito naman yung ating i-divide. 99 raised to 999,999 divided by 23. So, ganun lang din. Same process. A raised to equals 99, N equals 23. Then, the GCD of 99 and 23 equals 1. So, since they are both, they are 1. They are both, they are relatively prime to each other. So, applying the formula of Euler's theorem na 99 raised to p of 23 is congruence of 1 modulo 30 of 23. Since 23 is prime number, then subtract 1. Then 99 raised to 22 is congruence of 1 modulo 23. And excuse me, 999,999 divided by 22, ayan, which is 999,999 equals 22 times 45,454 plus 11. And then from here, we have to raise both sides to 45,454. That is 99 raised to 22 raised to 45,454. times 911, 99 raised to 11. Ayan. So, it is congruence of 1 raised to 45,454 times 99 raised to 11 modulo 23. And then, cancel this. Magiging 99 raised to 999,999 is congruence of 99 raised to 11 modulo 23. So, kagaya na lang yun ng pangalawang example kanina, i-divide lang natin yung 99 sa 23 kasi pag sinimplify natin ito, makukuha yung malaking number yon. So, mahihirapan tayong mag-divide. So, ang gagawin natin, we know that 99 divided by 23, so papalitin lang natin ito, di-divide lang natin siya sa 9923, which the remainder of this is 7. So, substitute 99 into 7. So, papalitan natin yung 99 sa 7. Kaya magiging 99 raised to 999,999 is congruence of 7 raised to 11 modulo 23. Then 7 raised to 11 divided by 23 is 22. Kasi yun yung remainder natin. As a remainder, 22 modulo 23. So this is the answer. 99 raised to 999,999 is congruence of 22 modulo 23. Ayan. So meron pa tayo mga 4 na examples dito. We have 5 raised to 120 is congruence of what is the remainder modulo 36. 3 raised to 44 equal is congruence of what is the remainder modulo 10. Ayan. 7 raised to 30 is congruence of what is the remainder modulo 15. And then 23 raised to 130 is congruence of what remainder modulo 25. Ayan. So, ganun lang din yung mga process. Kagaya lang ng una, kukunin natin yung GCD, which is yung 36 and 5 is 1. So, that is a relatively prime. Applying, second is apply the formula of Euler's theorem. So, 5 raised to p of 36 is congruence of 1 modulo 36. And we know that 36 is not prime. So, gagawin lang natin dyan, you have to use the p functions. P functions ng 36, yan, kumari 36 na yan ha, hindi yan b. There is, pwede nating sabihin na 2 squared times 3 squared. Ayan. And then, paghiwalay natin, we have phi of 2 squared times phi of 3 squared. And then, 2 squared, ayan, 2 squared minus 2 raised to 2 minus 1 is 1. And then, 3 squared minus 3 raised to 2 minus 1 is 3. Ayan. Then, 2 squared is 4 minus 2 times 3 squared is 9 minus 3. And then, simplify. 4 minus 2, that is 2. Times 9 minus 3 is 6. And then 2 times 6, that is equals to 12. So, tama yung sagot natin dito. Ayan. Hindi. Ayan, naging 5 raised to 12 is congruence of 1 modulo 36. And then, yung 12 na yan, divide natin sa 120. Kasi yun yung given natin kanina. Ayan. Ayan. Ayan yung given natin kanina. So, 120 divided by 12. So, since 112, divisible siya sa 12. So, magiging 120 equals 12 times 10 na lang. Ayan. Then, from here, 5 raised to 12, raise both sides by 10. Ayan. 5 raised to 12 raised to 10 is congruence of 1 raised to 10 modulo 36. And then, 5 raised to 120 is congruence of 1 modulo 36. So, hanggang dito na lang tayo. Wala na tayong i-divide dyan. Ayan. So, the answer is 5 raised to 120 is congruence of 1 modulo 36. By the way, addition lang ito, ang technique natin dito para makuha natin yung pinaka-remainder, dapat yung remainder natin is mas mababa doon sa divisor. Tandaan natin, kapag ang number is kapag ang remainder natin dito mababa doon sa divisor, ibig sabihin yun na yung pinaka-answer mo. Okay? Pero kapag halimbawa, mas malaki ito kumpara dito, ang gagawin mo dyan, divide. Kukunin mo yung remainder nun. Ayun. Next, ganun din. So, second example, yung kanina, ayan, 3 raised to 44. Sulat lang natin. Ayan, raised to 44 is congruence of what modulo 10. Ayan. And ito yung ano natin given natin kanina. Ayan. So from same, kunin natin yung GCD kung siya ba ay magre-relatively prime. So kung 3 and 10, ang GCD niyan is 1. And then the phi of 3 raised to phi raised to 10, phi of 10, I mean, is congruence of 1 modulo 10. So ang phi of 10 natin, check muna natin, ano, is same as phi of 2 times 5. And then same lang naman yan, same lang naman yung ating same prime numbers, subtract lang naman siya. 2 minus 1 is 1 times 5, 4, 5 minus 1 is 4. So 1 times 4, that is 4. Ayan. So tama siya. Ayan. So naging 3 raised to 4 is congruence of 1 modulo 10. And we know the 40, that is a 4. Ayan. 4 siya. Ayan. So, divide 44 by 4. Ayan. So, medyo tayo nagkamali. May tayong mali. Mistakes. Ayan. So, napalitan na natin. Ayan. Napalitan na natin siya, no? So, divide 44 by 4 using Euclidean algorithm. We have 44 equals 4 raised to 11 plus 0. Ayan. So, since factored naman siya, no? And then, from here, ayan. From here, 3 raised to 4. So, raise lang natin siya sa 11 both sides. So, magiging 3 raised to 4 raised to 11 is congruence of 1 raised to 11 modulo 10. Then, 3 raised to 44 is congruence of 1 modulo 10. So, the answer is the 3 raised to 44 is congruence of 1 modulo 10. And then, ayan. So, pangatlong example pa siya. And then, so from here, we have 7 raised, ang una natin gagawin pala is kunin yung GCD. Ayan, ang GCD of 7 and 15 is 1. So, tama. So, magiging 7 raised to 50, phi of 15 is congruence of 1 modulo 15. And then, the phi of 15 is 8. So, try natin kung tama siya. So, 15. So, pwede natin sabihin 3 times 5. And then, these are both prime numbers. We have 3 minus 1, that is 2. Times 5 minus 1 is 4. Then 2 times 4 is 8. So tama siya. Ayan, magiging 7 raised to 8. It's congruence of 1 modulo 15. Then, divide 30 by 8 using Euclidean algorithm. So from 30 equals 8 times 3 plus 6. So magiging, from here, raise lang natin siya sa 3. 7 raised to 8 raised to 3 times 7 raised to 6. Congruence of 1 raised to 3 times 7 raised to 6. So, after natin siya ma-raise sa 3, times natin agad siya both sides by 7 raised to 6. So, cancel na ito. Magiging 7 raised to 30. Congruence of 7 raised to 6 modulo of 15. And then you have to divide 7 raised to 6 is 15. The remainder is 4. So, the answer is 7 raised to 30 is congruence of 4 modulo 15. Then last example here. Apply that you must get the GCD. Ayan, of 23 and 25. Which is on the 23 and 25, the greatest common divisor of 23 and 25 is 1. And then apply the formula of Euler's theorem. You have 23 raised to p of 25 is congruence of 1 modulo 25. Then 25 is the same as 5 squared. Ayan. And then apply yung third property of tosine function. Yung sa tosine function natin kanina. So 5 raised to 5 squared minus 5. Kasi 2 minus 1. 25 minus 1. 5. That is 20. Ayan. And then yung 130 divided by 20 using Euclidean algorithm. Then 130 equals 20 times 6 plus 10. Ayan. Ito yung equation natin is 130. And then from here, so 23 raised to 20 times 6, raised to 6. So i-raise lang natin siya sa 6, then multiply both sides by 23 raised to 10. Kaya magiging 23 raised to 20 raised to 6 times 23 raised to 10 is congruence of 1 raised to 6 times 23 raised to 10. So, cancel natin to. Magiging 23 raised to 130 is congruence of 23 raised to 10 modulo 25. So, malaking number yan. Napakalaking number niyan pag sin-evaluate. So, ang gagawin natin, kukunin natin yung remainder ng 23 and 25, which is the negative 2. So, yun ipapalit natin sa 23. Magiging 23 raised to 130 is congruence of negative 2 raised to 10 modulo 25. And then, negative 2 raised to 10, we have 5,024, I guess. Ayan. Modulo 25, then divide dun sa 25, the remainder is 24. So the answer is 23 raised to 130 is congruence of 24 modulo 25. Ayan, so pwede nyo ring itry yan. Pwede nyo namang i-post yan kung pwede nyo itry. So yun yung mga given natin para mahasa kayo doon sa ano natin. No? Ayan. So, dako naman tayo dito sa last digit of powers. Ito yung tinatawag. So, using Euler's theorem. So, by the way, ang Euler's theorem, ginagamit din pala nito dito sa mga to. Kung identify natin kung ano ba yung mga last digits ng mga ito. Okay? Ayan. So, first, we have find the last digit of 555 raised to 5. Find the last digit of 1847. Find the last two digits of 791. Then find the last two digits of 3,333 raised to 4,444. So first, ito muna natin sagutan. We first note that finding the last digit of 55 raised to 5 can be obtained by reducing 55 raised to 5 modulo 10. So, ibig sabihin, since the last digit lang naman ang kinukuha natin, tandaan natin kapag last digit, yung unang last, yung sabihin, yung pinaka last digit, isang last digit lang, gagawin natin siyang modulo 10. Parang i-divide natin siya sa 10. Kapag 2 digits, last 2 digits, divide naman sa 100. Ayun, ganun lang siya kasimple. That is evaluating 55 raised to 5 modulo 10. Then we know that GCD of 10 raised to 55 is 5. So kung mapapansin niyo, hindi siya relatively prime. Yung dalawang pair na ito. However, we know that 55 has a prime power decomposition of 55 equals 5 times 11. So, ito yung sinasabi ko na kapag hindi relatively prime yung dalawang number natin, pag kinuhanan natin ang GCD, meron ka pang ibang gagawin. Ang gagawin natin dyan is yung pinakamalaking number, yun yung gagawin natin prime power decomposition na tinatawag. Ibig sabihin, kukunin lang natin yung prime ng isang factor ito, which is 55 equals 5 times 11. So, sabihin yung 11 na yun yung prime. And then also yung 5, syempre. And then, kunin natin yung pinakamalaking number. We have GCD of 11 and 10 equals 1. So, hence, it follows that 11 raised to P of 10 is congruence of 1 modulo 10. And we know the P of 10 is 4, which is 11 raised to 4 is congruence of 1 modulo 10. Ayan. And then, ayan. So, para mag-equal dun siya sa 55 raised to 5, multiply lang siya kay 55 raised to 5 raised to 5 raised to 5. So, bale, 5 raised to 5 yan. Times 11, ayan. So, times 11, pwede natin sabihin na times 11 times 5 raised to 5. Modulo 10, ayan. Let's say, halimbawa lang, ayan. And then, we have to simplify. We have 55 raised to 5 na siya. Is congruence of, wala na yung 1, magiging 55. So, magiging 11 na lang yon raised to 55, raised to 5 modulo 10. So, ito na siya. So, ito. So, magiging 55 raised to 5 is congruence of 5 times 1 kasi, kasi kukunin natin yung remainder ng dalawang ito. So, ang remainder ng 5 raised to 5 is 5, then 11 is 1. So, 5 times 1 is 5. So, therefore, ito yung pagbabasihan natin. So, ito yung last digit. Hence, the last digit of 555 is 5. So, kapag hinan natin yan, yun ang magiging tamang sagot. Next. We first note that finding the last digit of 89 raised to 47 can be obtained by reducing 89 raised to 47 modulo 10. Ayan. So, ganun lang. Same lang dun sa nauna. So, since yung 89 and 10, so this is 89 and 10. Ayan. Hindi ko lang siya na-edit. Sorry. Or is equals 1. Ayan. Hence, it follows that 89 raised to p of 10 is congruence of 1 modulo 10. And then, 10 is 4. P of 10 is 4. 89 raised to 4 is congruence of 1 modulo 10. Then, we have to, then using the Euclidean algorithm, kagaya ng nauna. Ayan, sorry. Stop. Ayan. So, yung 47, divide natin, equals 4 times 10 raised to 7. Plus 7. Ayan. So, ito yung ating Euclidean algorithm natin. Kaya 89 raised to 4. From here, raised to 10, both sides. Then, times 89 raised to 7, both sides. Magiging 89 raised to 4, 10 raised to 10, times 89 raised to 7 is congruence of 1 raised to 10 times 89 raised to 7 modulo 10. Then, cancel this. Magiging 89 raised to 47 is congruence of 89 raised to 7 modulo 10. So, malaking number yan, i-reduce lang natin siya. Kunin natin yung remainder ng 89 and 10, which is si 9. Kaya naging 89 raised to 47 is congruence of 9 raised to 7 modulo 10. And then, simplify natin and divide sa 10. The remainder is 9. So, ito yung pagbabasihan natin. Hence, the last digit of 89 raised to 47 is 9. So, yun siya. Next, we have 7 raised to 91. Ayan. So, ang kinakama natin dito, yung last 2 digits. Ayan, may mali na naman tayo. Ayan, last 2 digits of 7 raised to 91 can be obtained by reducing 791 modulo 100 is evaluating 7 raised to 91 modulo 100. Then we note that the GCD of 107 equals 1, hence it follows that 7 raised to P of 100 is congruence of 1 modulo 100. The P of 100 is 40. Ayan. So, magiging 7 raised to 40 is congruence of 1 modulo 100. Then, applying the Euclidean algorithm natin para makuha natin yung 91. Ayan, yung 91 is equals to 40 times 2 plus 11. Kasi 40 times 2 is 80 plus 11 that is 91. So, from 7 raised to 40, squared natin siya both sides, times 7 raised to 11 both sides also. So, magiging 7 raised to 40 squared times 7 raised to 11 is the congruence of 1 squared times 7 raised to 11 modulo 100. Then, cancel. Magiging 7 raised to 91 is congruence of 7 raised to 11 modulo 100. Then, the 7 raised to 111 raised to 11 modulo 100. Sa pag sinimplify natin yan, pag dinivide natin yan, ang magiging remainder nyo is 43. So, magiging 7 raised to 91 is congruence of 43 modulo 100. So, ito yung last 2 digits ng 7 raised to 91. So, the last digit of 7 raised to 91 is 4 and 3. Last. Ayan. So, ito na siya. Last 2 digits ulit yan. Ayan. We first note that finding the last digit of 3,333 raised to 4,444 is modulo 100. So, yung 3,333 and 100, ang GCD nila is 1. So, ganun lang din ang gagawin natin, kagaya lang din nung kanina. So, 3,333 raised to P raised to P of 100 is congruence of 1 modulo 100. Then, the P of 100 is 40. And magiging 3,333 raised to 40 is congruence of 1 modulo 100. And then, ayan, raised lang, para makuha natin yung 4,444 using the Euclidean algorithm equals 40 times 11, 111 plus 4. Ayan. magiging, ayan, so from here, raise lang natin siya both sides by 111 and multiply by the 3,333 raised to 4. Kaya magiging 3,333 raised to 40 raised to 111 times 3,333 raised to 4 is congruence of 1 raised to 111 times 3,333 raised to 4 modulo 100. Then cancel, magiging 3,333 raised to 4,444 is congruence of 3,333 raised to 4 modulo 100. And then, malaking number yan. So, reduce lang natin, papaikliin lang natin yung number. So, ang gagawin natin doon is, divide lang yung 3,333 sa 100. Ang makukuha natin remainder dyan is 33. Kaya magiging 33 raised to 4 modulo 100 na yan. So, pag dinivide natin sa 100 yung 33 raised to 4, ang makukuha nating remainder is 21. Kaya, ang last digits of 3,333 raised to 4,444 is 2 and 1. Ayan, so, ayan. Screenshot nyo lang din or kaya i-post para masagutan nyo lang din. So, ito lang po yung aking discussion. So, that's all. Thank you for listening. Sana may natutuhan po kayo. Thank you guys and God bless.